Hey everybody, back with another video. Like I always say, I wasn't planning to film anything. A buddy, Arcade Buddy Electric Dreams on Clove, wanted me to test out his Moon Patrol boards. I already put them in the cabinet and started troubleshooting it, and I was hoping it would be something simple, but might end up having to do something that might be interesting. So figured I'd film. So what I've done so far is this is his bottom two boards here, and I already tested his soundboard and it works good, and I put a check mark there. And then I took his second board, which I think is a ROM board. I'm not sure. I'm gonna have to look at this. Maybe this is a CPU board. I don't know all the nomenclature yet. And I put his soundboard, his CPU board, I guess, with the dip switches on my board set, and we got problems. Then I took my CPU board and my soundboard on his other two board sets, and the game plays, but we still have some problems. There's some graphic issues going on. So what I figured I'd do is let's focus on this board first and see if we can address the issues on this board right here, because I know his soundboard works. So I'm going to put this in the cabinet, show the Symptom, and then we'll come back and look. Got my Williams row on and my Moon Patrol pulled out, so there's the board set there. These are his top two boards, so the soundboard, and I'm calling it CPU board for now. So that obviously doesn't sound good. And we got some weird stuff going on, right? Can't coin up, it automatically coins up or something. I don't know what's going on. But obviously something's wrong with the board. Alright, so on switch 2, if you put switch 2 dip switch 8, it's supposed to go boot into test mode. I've never had to try that or even read the manual to know how to do it, so I'm going to try that. The other thing is, see, that's an LS244. Interesting that there's like a capacitor tied to this C8 on his board, but on mine C8 I have that same capacitor, but I also have capacitors tied onto C10, which is a 244. So I don't know, if that's an additional mod why they did that. Come back to that hopefully, maybe. The other thing I noticed is this, I think, said ROM 4, but it's written with ROM 3. So I don't know if the label's wrong. My other one I don't think says that, does it? No. Weird. So I'm sure this is fine, but we're going to put this in and run the self-test and see if that gets us anything. Alright, that was it's booting up into test mode. See if we get anything on the screen. It's supposed to run a RAM and a ROM test automatically, but I haven't done this with my working board, so no idea what it doesn't look. It should be giving me a ROM okay or a RAM error or something, but it's not giving me either one. Let me power cycle it real quick. Let me. I didn't get that sound the second time. Might have to run this with a normal board in there just to see what it looks like normally. Interesting. I think something's got to be jacked up with the ROMs. I'm going to go read the directions, see if it says anything. Alright, this is my working board set. I had to hit player 2. That's supposed to advance it. NG99. RAM okay, NG99. I think that's bad, but this is with his two bottom boards, the video boards and stuff. So let me put his board back in and see if I can get this to come up. This says RAM okay, ROM 0, NG99, ROM 1 okay, FF. Let me wonder why my board's reporting that. Alright, this is my CPU board. Alright, something definitely jacked up with this board. Let me power cycle it. I mean, it's going. I don't even know if it's running the test. I hit player 2. Yeah, something's jacked up. Alright, so I'm not showing everything, obviously, but I read all these ROMs in ROM ident, and they read good. I checked this 244, which is socketed. I tested that, which is good. And then I'm going to try a different Z80 in here and try that. Otherwise, I'm probably going to have to hook up an adapter on the bench and start looking at the address buffers, which are like right here. These are the address buffers. You're gonna, either something's not getting in or out of RAM or ROM correctly. I could probably just socket. This is probably the only RAM. I have to look at the schematic. I could socket that and see if that helps, because it's not even going into test mode. So it's either, the RAM, and part of the RAM is probably needed to run some of the test code. So let's try this Z80 and see what we get. Still garbage. It's not running test code at all. So it's got to be probably that RAM chip would be my first guess, and then if it's not that, we have to go look at address lines and buffers and data buffers coming out of the RAM and stuff. Alright, I was able to pull out that 2128 and put it in my B&K here. I already tested it. Oh, now it says it's good. Dang it. It said it was bad before. Or is that the one I had? Is that mine or his? Yeah, I think that's his. Yeah, shit. So it's not RAM. I don't think it's RAM. Damn. Alright. Okay, I'm back at this. It's actually, I think, a couple months later. Since I was messing with it in the cabinet, and since then I went and got an arcade shop JAMA adapter. I had to order some stuff anyway, and so this just makes my life easier. So I have an arcade shop JAMA adapter. I put my board set back together minus the soundboard, and we're going to put dip switch 8 so we can see what the boot test mode looks like with a working stack, obviously minus the soundboard. Where was I at? Yeah, obviously fixing the memory, I think, is where I left off on Electric Dreams. This did not fix it, but let's go ahead and boot this up and turn down my contrast there. This is the test screen. I figured I'd film it this way instead of going back and forth. I hate actually working on games in the cabinet. So much easier at a workbench like this. Alright, so you see here it says ROM 0, not good, 99. That is because I have a high score save mod or something, or a free play mod. That's what it is, not high score save. I have a free play mod on my Moon Patrol, and that is why ROM 0 shows bad. So we know my board set is still working. If I power off, just a document here, so working fine. Moon Patrol's working. Okay, so this is my board set. We are going to put his CPU board on my board set and do the same thing, and then we're going to start probing around and seeing what's going on. Alright, this is the problematic CPU board. I think I have my new CPU in there. I don't even know what I did with the other one. Oh, I do know what I did with it. Alright, we're not getting sync. It's part of the problem. That seems odd. Something is jacked up sync-wise, it looks like. Let me just do the dip switches the same way I have mine. 5, 6, 7, 8 is up. 1, 2, down. Yeah, something is not right there. What's going on there? Alright, well, let's try it with the dip switch 8 on. See. Yeah, something's definitely not right. Wacky. I don't know where I was holding the camera. Well, that's something that's new, isn't it? That is not what we were getting in the cabinet. Alright, this is my CPU board on his 2 bottom boards. I'm just getting myself familiar again with the situation here. And what's going on? We don't see anything. Don't see anything on the screen at all. What the fudge? Dip switch 8 is on. Alright, well, in test mode we're getting something. Maybe this is what... Okay, there we go. In game mode we weren't getting jack. I might need to mess with the dip switches. I might not have it set up correctly. That's interesting. This is my CPU board, and it's reading that ROM 2 is not good, which is odd, right? Interesting. I'm gonna go back and just see if anything changed on my CPU board. I just figured this out because I was swapping them. So yeah, this is my board set. ROM 2 is on the middle board. Yeah. This is my CPU board. That is ROM 0, ROM 1. Is it? This is where it's confusing a little bit. So this is his board, and it says ROM 0, ROM 1, ROM 3, ROM 4. These are just mislabeled. That's what's throwing me off. Because this says there's ROM 1 and ROM 2 on the middle board too, but I assume that test is actually only testing these ROMs. So ROM 0, ROM 1, ROM 2, ROM 3 is what it's supposed to be labeled. Like mine is here. It says ROM, well, I have it replaced ROM 0, ROM 1, ROM 2, ROM 3. Okay. I'm sure this is not the ROM 2. This is on the graphic, so. Alright, never mind. Alright, just to document, my board's still good. I have to, it wasn't good right away. I had to kind of mess with it a little bit. I don't know, it's kind of finicky, so definitely need to be careful here. Going to go back his CPU board on my board, and let's just start troubleshooting. Enough swapping around. Alright, so I have this hooked up to my Fluke over here, and I was getting bad power supply. So anyway, I was troubleshooting that, saving you guys the pain here. But let's go ahead and power it on. And I have this bad power supply loop enabled. Still got the weird scrambled screen. But if we look at, hopefully you can see the glares, there we go. If we look at the 5 volts 4.5 volts. And I don't know why it's so low on this board, and obviously my other board was booting. But let's go ahead and adjust the power supply. Let's see here. And I'm just gonna, I'm turning it up here. Let's see what we got. Alright, well, it didn't clear on its own. Last time it just actually cleared. Now I'm actually at 4.9 volts. But my 12 volts is pretty high, 12.5. I don't really like that. But we got data bit 0 tied high on this. So we know there's a problem, I think, on our address bus. But I just figured I'd show you that it's... I had that bad power supply, or what was it called? Whatever. You get the idea. And then it was actually a voltage, too low of a voltage. So the Fluke is actually detecting the voltage, and I guess it didn't have a good enough 5 volts on the 5 volt pin or something. So I had to turn it up some. But I don't know why I had to do that. So there might be something on this board, kind of getting warm or something like that. I'm not sure, but we'll figure it out. But also there's obviously something wrong. Data bit 0 tied high. Let's do a bus test. Data bit 0 tied high, tied low. Data bit 0 tied low. Let's do a continue. And 1 is tied low, and 2, and 3, and 4, 5. All of them. So, alright, let's figure, we didn't have it on loop, so now, sorry for the damn cable like that. Alright, so now I have it looping, and let's adjust the power supply without even looking at the meter. I just turned it up until I got a good power supply, and then if I check it, we're at 4.7 volts and 12 volts, so... You know, still 4.7 is not great, but it does say good power supply. So let's hit stop. Bus test. Okay, so we're back to where we are with a little bit better voltage situation. Alright, and still need to look up that error. Data bit 0 tied high. I think that's the address bus. I'm pretty sure. So I gotta look up the schematic. Alright, so I'm looping on the data bit 0 error, and I got my scope on. And I'm going to come to the enable pin of this, I think it's 5M is that buffer right there that goes to the CPU on the data bus line. So obviously data bit error, data bit 0 error is data line 0 is tied low. And if let's look, what's data line 0? Pin 16, so this is 20, 19, 18, 17, 16. I don't even have a trigger, but... Now it's kind of triggering, but it's definitely low. I don't know why I must not have good ground or something like that. I don't know. It's not really triggering very well. But yeah, it's zero, it's low. But if I go to the enable pin, it's high. Again, I got messed up trigger, but so this chip is not being enabled. I would assume that it's supposed to be enabled during this kind of test. I would assume. I'm not positive. I might put my CPU board on just to double check that behavior. But then basically that enable pin's driven by this LSO2 at 5J, and then I have a LSO4 at 2E. So I might just break out the logic comparator, and then I don't know how that enable pin's getting set. Maybe from memory request and this LS367. No, it says IORQ. Yeah, it comes from this 4K IORQB. So 4K, 2E, 5J are our suspects right there. So let's first measure my board's voltage real quick. And I didn't even touch the power supply, and there's definitely a voltage difference between my CPU board. Like, I think, what were we at, 4.7, so a tenth of a volt, not a lot, but there is a voltage difference. So got the Fluke hooked up. Obviously bus test is okay, so how do I the bus test is okay, so how am I reproducing this? Let me think about it. Alright, so I'm looping the bus test, and this is my direction pin, pin 1 on that buffer chip right there. Let me switch hands here with the camera. If we come to pin 19, see, I'm getting hard to do with one hand here. Alright. Let's see if I can get this trigger to stay happy. It looks like it is, like, I don't know if you guys can see it on the camera, but if I slow it down enough, my seconds per division, I do see it going low. I might need to hook up my logic probe. This is where it kind of sucks for some reason. But you can kind of see it going low, and I don't know if it was doing that on my other one. Let me hook up the logic probe real quick. Alright, so here's my logic probe right here. Let's go to... And yeah, we know it's toggling. So let me hook back up the bad board, and if that's not toggling, that's definitely our problem, I think. That data buffer chip with the bus test looping should be definitely toggling the buffer enable, so I wasn't sure for sure, so always good to verify. Got, the bad CPU board back in, data bit 0, tied low. Come to this data buffer, and it is low. So we need to go backwards now with the logic probe, probably instead of the oscilloscope, make it a little easier. I don't know why I'm not getting good on the scope, but anyway, we'll mess with that later. Right, so 5J, we got to come to that. I don't know what that is, but anyway, 2 or 3 should be toggling to get one to toggle, that's for sure. That's 5J LSO2 pin 1 is high, 2 is low, not toggling, pin 3. So that is probably good. Let's come to pin 2E pin 4. 2E LSO4. Yep, pin 4. 1, 2, 3, 4 is low, and that's probably driven by 3 and 2, I would assume. And then the other one's 4E pin 8. 4E pin 8, LS30. 4E pin 8, but I bet that's not toggling either. 1, 2, 3, 4, 5, 6, 7, 8. Right, that's low. I don't know. I'm going to have to put a logic comparator on here because that 4E, I mean, look how many things are coming in there.
I mean, to make pin 8 go. So I'm just gonna. I think I have break out the logic comparator would be the easiest thing. LS02, LS30.
Well,
Let's do that.
The LS30 looks good, so it's probably not that, according to the logic comparator. All right, so let me stand up. I've been messing around a little bit. This is 4K, which is the 367 here that feeds into or generates the IORQB or whatever. But that looks good. And since I was just screwing around, I figured I was just messing with, I had the logic comparator out, so if I can get this damn thing on there. There we go. But 4J looks bad. But 4J is on the address buffer side, which is kind of weird. Like, what's that have to do with the, well, 15, does A15, oh, you know what? A15 control goes into 4F, which feeds 4E. Yeah. And what lines are bad? 11 and 13 on 4J. No, those aren't 4. Those aren't 11 and 13. I gotta find 4J 11 pins 11 and 13 and see what they do, if anything. Oh dang! I thought I was on to something. All right. Sorry if that was out of focus. I have no idea. I'm not looking through the viewfinder. Here's 4J, but obviously the outputs for address line 13, 14, and 15, which also have something to do with feeding 4E, which comes to the ultimately to the enable pin of that. But that's not the problem. I gotta find 4J on the schematic. All right, if you can see this, 4J is down here. I don't know what it comes into the data bus. I don't know. I assume the chip is bad, but I don't know if that's our problem. I'm gonna go ahead and replace it, I guess, because I can't find a smoking gun yet. Maybe if I check 4F, LS138. I checked basically all the chips that are in this enable path for the most part, and nothing's a smoking gun yet. I haven't checked 4F. That's the only thing right here. All right, I've been probing around and really just guessing and and stuff, but I hooked up. Actually, what did I do? Never mind. 1H. It's a 367. Every single output is bad, and they all go to the data bus. But to the buffer data bus. I don't know. So that could be obviously a problem as well. I'm gonna go ahead and replace. Looks like there's potentially 2 bad 367s here. I'm gonna pull them out and hope for the best. See if we make some progress, because obviously at least those are bad. Nothing else is giving me a clue. And I mean, looking at that enable line on that buffer chip, I tested out basically every single chip that leads up to that. 4K, 2E, 4F, 4E, 5J. Yeah, I don't know. All these address lines are low at that point. Like 12 through 15 are low. So the only thing coming into 4F, if you can see that, is memory request or refresh something. I don't know what those do. So, but anyway, there's stuff that's not right on the data buffer. So let me do that. Replace those 367s. I figure I just back it up. I don't know. It's definitely not running code, right? I don't know what's going on here, but without the Fluke hooked up, my enable pin on that data buffer, the LS245, is toggling like crazy. Just makes me believe that that's working correctly, but we're not in reset. 1, 2, 3, 4, 5, 6. So that's good. Should be high, and we have good clock. I just kind of skipped over that part. At least I think we do. Seems like we do. This thing is definitely doesn't seem right. all the outputs are low, which is obviously bad. So that could be our problem. I don't know, maybe went down the wrong path with this enable on that 245, I'm not sure, but I am going to replace these two 367s, and I'm going to do it tomorrow though, it's getting late. So okay, so it's the next day, and I went ahead and replaced these 367s, tested it, this actually is a new one, but I tested them in my TL866 and they tested fine. And so I think that's like kind of some false reading for whatever reason on the logic comparator. Both of those tested fine, had the same behavior, and then started looking at the Fluke manual about what it does when you hit the bus test. Let me see if I can show this real quick. Let's see. Yeah, basically, you know, the bus test first. Let me see if I can. Alright, whatever. First it tests for the control lines, whether they're drivable or not. Then it tests whether address lines are tied high or low, or address lines are tied together. Then it tests if the data lines are tied high or low. So we know that the control lines and the address part of the address bus is somewhat decent, obviously. But the data bus was tied, data bit 0 was tied low. So then I started thinking about it, and really that LS245 is the only thing connected to the data line of the CPU. And so I figured I'd cut line 4 of this data bus. The whole enable thing got me going down the wrong path here. I cut pin 4 right here, the LS245, and now let's run a bus test, and now we get data bit 1 is tied high. So if I cut pin, what is it, pin 3? If I cut pin 3, like that, power back on, do a bus test, data bit 2. So now we're fixing our data bit 0, 1, 2, and 3 just by, so this LS245, which I cannot check in my comparator because it's 20 pins, is likely bad. So let me replace this LS245 and see where we get. By the way, I'm doing this without the CPU board on the regular board stack, so I just removed it and I can run the Fluke on it just like that. So I think we're making some progress. I was down the wrong path there with that enable thing. Okay, so I have the 245, yeah, 245 replaced. Power on. Let's do a bus test, and our bus test is good. So let me hook this board back up. I had taken out the ROMs and stuff, so let me put the board back up and see if we got a good CPU. Here we go. Cross your fingers. Let's see. Double checking I have everything inserted correctly. No sync. Weird. We have some sync issue, I think. That is interesting. Yeah, because this is my bottom boards and his top boards, CPU board. Yeah, we saw that before, that sync issue. Oh, well, it's somewhat, yeah, it's definitely a sync issue, but it looks better when I'm going through the test mode. I don't know if test mode's actually running. Alright, I've been messing around a ton. I checked all the horizontal counters and vertical counters. You can kind of just check them on the
CN1 and CN2. But I just, you know, recorded what they were, and it all looked like they were good. That was coming out of all these buffers over here. I checked all the horizontals, and if I look at, I don't know if I've shown this yet, but basically this CPS jumper right here is for composite sync, I think, CP sync or horizontal sync. So that jumper determines whether you have composite sync or horizontal sync, I guess. And I have good 15.6 hertz, but obviously no sync. So what I did is, thinking that maybe there's a problem between here and my board, my JAMA board, just gonna come wired up a little sync here just to touch it, and we get sync, and it says RAM no good. So let me figure out what, and let me tell you that I spent like an hour checking out all the horizontal counters and shit. What a pain in the butt. And it just ends up being some type of connectivity issue, I think, from this composite sync thing. So let me figure that out, what's broken between here and my board, and then we'll go from there. All right, I don't know if you can see it, but right there's some type of glue or something on the PCB fingers, and so if I push it in too much, it might not be making contact. That's my best. I ohmed it out, and it should be there. So let me try to clean this up somehow with some goof off. I cleaned it up with an eraser, and I think I got most of it, but I still need to do a better job because I pulled the edge connector out, and now I have sync, right? But if I push the edge connector all the way in, now it's seated in there all the way. Oh, okay. Well, I still have it. Seems like it's better, I guess. It was just gunk on the edge connector. Crazy. All right. So now let me look at the RAM issue. RAM not good. All right. So the cool thing is, it says here in the RAM test in the guide, it says if RAM is shown to no good at address E000 to E7FF, and we got it, the error was E000. It says you have a failure at 3B or the decoder at 2K, which is the chip enable, which drives the chip enable. So 3B was the RAM that I had replaced, and I just checked the read-write lines, the read lines, the write lines, and the output enable or chip enable. And I think, what was it? It was, yeah, the read line output enable pin number 20 did not have continuity, so I had to put a jumper in there. I must have missed a spot somehow on soldering that or something. So quick little jumper. Let's see if it fixes our issue. I got the CPU in, memory. Nope, still busted. Damn. The hell? It says E0 something. I don't know. I thought that was it. What the heck? Yeah, it says RAM not good. E00. Can't read this first chip at 3M. I'm not sure why. I guess I'll put it back on my Fluke too and show you that. Fluke connected. Do a bus test. Alright, RAM short at E000, enter E7FF, I believe. Yes. Okay, so we get a read-write error on that address line, BTS80 loop. If we hit continue, we get the same error on each address line, or each address, I should say, not address line, but each address. So let me look up BTS 80. I think that's going to indicate some data line, I think, but let me double check. Alright, I think I have it figured out. So this is the address, and then it's 80 is like a hexadecimal mask. telling you which bit was not read-writable. So if it's a 1 in binary, then that's the bit, that the data line that basically wasn't read-writable. If I come over here, go to my calculator, 80, there you go, 80 in hex equals this in binary, and then you count from the right to the left. That's data line 0, 1, 2, 3, 4, 5, 6, 7. Data line 7, go to my drawing over here, if you can see it. Let me make it bigger. (3B) data line 7 is pin 17, and it looks like I have another mess up because I'm not going to be able to do this probably with one hand, but if I hold this here, maybe. Anyway, pin 17 does not have continuity with the other pin 17s of the other sockets that aren't populated. So I think there's a problem with my little repair there. So let me go back and fix that. We're getting better, but we're still getting errors. So we got a read-write error to address E0, EE, BTS, FE. If I loop on that, you can see it's clearing. It's like on and off, on and off, on and off. To me, it kind of seems like it's a decoding error, but if I hit continue, there's like no consistency, you know what I mean, except for maybe the address, I don't know, but see, it says BTS F8, FE, FF, AD. I mean, I can check to see if there's any consistency there, like translate in hex. What's FF? That's all ones, obviously. FF in binary is all ones, like that. If I hit continue, yeah, 0, 1 in hex. I don't think that's 0, 1 in binary. There's 1, of course, duh. But yeah, I mean, it just doesn't seem like it has to do with the data lines. I'm thinking it's got to be like a buffer or something else going nuts, or the decoder. The decoder is this LS139 right here. If you can see that at 2K. I might put my logic comparator on that real quick, see if that shows. All right, so I could have probably figured it out with the addresses, I guess, but I ended up ohming it out again. Found pin 1 of that RAM, which is address line 6. Am I right? Or is it address line 7? So I think it's address line 7. But anyway, fix that, I think. Let's see. Plug this in. Right. I'll be right back. Power it up. And let's repeat. And we're running our test now. It's not airing out, so that's good news. I think we might have fixed it. Probably half the problems were caused by myself. Looking good. Alright, RAM short was fine. Let me put it in test mode right now. So hopefully we get something. It looks like it's testing the ROMs maybe. Because I think it does the RAMs right away. Yeah, and then it's the graphics RAM. So it probably goes working RAM, ROMs, graphics RAM. And everything's good to go. Okay, okay, okay. Let's power it off. And we have working Moon Patrol. Alright, so the CPU board's fixed. Made some progress finally. What did I have to do? I didn't have to replace these LS367s. Were led astray on that through the enable pin of this LS245, and then I was using the logic comparator, and for whatever reason it showed those as bad, but they're not. Then the LS245 was bad though, right? Yeah, the enable wasn't working. Yeah, it was bad. I had to cut those out, cut the data lines, and that was that buffer is what was bad there. And then I probably never had to replace the RAM, but because I did, I bodged up a couple traces and had to fix those. So now we're working. So I think the only thing that was really truly wrong with it was this buffer chip. Unfortunately, I did a lot more than I needed to, and also the sync. I think my adapter wasn't making contact on the sync pin, the opposite side of pin 10, whatever that is. So, all right, onto the other board. Let me put this onto his other board. All right, actually, I think, I don't know which one of these chips is his. I have one of my memory chips in here, but I think they're all good. Anyway, let's power it on. I have his board stack on there. And it's something doesn't look right? Or is it working fine? Is that 100% right? I don't even know. Yeah, it looks 100% good. No, I thought his board, something was wrong with his boards, his other boards, when I put it in my cabinet. Oh, there's no background, I think, right? Let's put it in the test mode. It says RAM okay and ROM's okay. I thought something was wrong before, but maybe it was all just the CPU board. No, because I don't know. I have to go back and look at my damn video. What the hell? There's supposed to be mountains or something. It's missing something in the background. All right, let me think about this a little bit. I think something's not right. I don't think. All right, so this was missing. I think Electric Dreams had given this to me loose, and there were some broken pins. I don't know if those pins are actually still in the socket or what, but I assume that it goes right there. So I'm going to have to take a look at it and see what this is. Probably some type of bipolar PROM, I would expect. So let me do some investigation. I'm going to have to remove this and see what it is. I pulled this off of my board. Looks like it's probably a common replacement. It could be a bipolar PROM. I don't know. I'm going to have to look it up. But I'm going to put mine in there real quick and put his boards back together and see if it works. To be what it was. There we got our background and everything. So I'm going to look that up and see what it is. This looks to be working, I guess. Yep. Alright, cool. Let me look that up and see if I actually have any or can burn these. Hopefully I can. I don't know if you can see it, but this is a... Let's see if we can see. Texas Instruments 18S030, and that is the same as the 82S123 bipolar PROM, so I programmed that. I'll put these boards back up. All right, and let's cross our fingers here. Looks good. I don't know about the sound, but yep, sounds good. I can't do this with one hand. Yep, I hear all the sounds. Let's play one more. Let's play one. Whoops. Used to playing this on the, not on a controller. I don't know why I jumped. That was dumb. Electric Dreams, it's working, man. Took me a lot longer than it even needed to. God, I suck for some reason. I saw that coming. Seems like it's working to me. I would say that's a success, even though I totally... what did I do? I bodged up that RAM. I had to make a couple jumpers, actually. It wasn't my best RAM removal job. But we had a bad PROM and a bad LS244. I think that's all it was. For the most part. Yeah, I don't think it was anything else. Oh, but the sync thing was trippy, huh? I had to clean up there was some goop on that edge connector, which was weird. So, alright guys, that's it. Moon Patrol's done. And I learned a little bit more on the Fluke, so I'm glad I was able to use it. The more I use it, probably the better I'll get, so. Alright, cheers, bye.